For the water treatment calculation, we have to design as per NBC for the Indian project. So for if you going to design for other some Gulf project or Singapore project, you have to see the local code and the standards for the water demand calculation. Slightly for each code slightly varying. 10 to 20% may be varying according to this local code and norms. For the Indian project, we have to refer the NBC code. In that NBC code, what the NBC telling? They are telling for the residential building, how the residential buildings are considered, how the other than residential buildings are considered. Like that, they are telling. First, you have to refer the table. For the residential building accommodation, they have told accommodation, population, one bedroom dwelling unit. If you are going to design for one bedroom apartment or any building, you have to consider minimum population requirement is 4 numbers. 4 people are going to stay in the one bedroom dwelling unit. For the 2 bedroom dwelling unit, 5 people are going to stay. For 3 bedroom dwelling unit, 6 people are going to stay. 4 bedroom dwelling unit, 7 people are going to stay. Other than that, some bungalow or some other customized building, client have to tell the occupancy or water requirement, water demand, everything. Client have to tell. So for the standard typical building, you can take from the NBC code. Otherwise, if the customized building or bungalow, any residential building, client only will tell how much water I have to store or any other special facility requirement is there or not, like that. Client only will tell. So otherwise, you have to design as per the NBC only. So single bedroom means four. For if 4 bedroom means 7 people are going to stay. For the this people only, you are going to give you a water storage and water supply, everything based on this table only you have to give. Suppose you are going to design other than residential means, some of the table scenario you have to consider. Other than residential means you have to consider occupancy rate based on, or if you are going to design for office building, population requirement they are told 1 person per 10 square meter. For the 10 square meter, you have to consider 1 person. 1 person going to stay in 10 square meter. If it is office building, if you are there are some noises coming. Please switch off the speaker. So based on the tables, NBC tables, you have to decide what type of building you are going to design. So for the building, you have to take the occupancy rate from the population requirement table in the NBC. So based on that, you can come to know how much people going to stay in this total area, like that. So for the office building, 1 person for 10 meters square for every floor. You have to go total floor. Total floor area you have to calculate. Then you have to divide 10 meters square. Then you can come to know the total how much people is going to occupy for this building. Based on that, you can get the population, total population. If it is school, strength of the school, total strength of the school plus teaching and non-teaching staff. Strength of the school, who will tell? School management have to tell that this school is how going to decide for the how much strength. That and all school people will tell. Strength of the school student plus teaching and non-teaching staff. If it is hostel, number of bed plus 4.5 into warden's residence plus staff. Everything you have to consider. Hostel, number of bed plus staff plus requirement of restaurant seats. Hotels means number of bed plus staff. If it is 5-star hotel, number of beds will be there. Staff, service staff will be there. Requirement of restaurant seats. How much restaurant seat you are going to provide? Like that, everything you have to consider. Hospital, number of beds plus staff, pattern attenders. Like that, you got to consider. Accordingly, for merchant, one person per 3 meters keep of street floor and everything. Traffic terminal. So average number of users per day. So everything they are given in the data are given how to take the population requirement for the other than the residence building, everything given in the NBC. Based on that only you can take. Otherwise, client will tell. So how much suppose school means the client will tell how much student will be there, how much staff will be there, everything client will tell. Based on that one, based on the data, we can also design. So now we will go how to design, how to take the water load. Water supply for residence 4.1.1 water supply for residence. This is taken from the NBC. A minimum of 70 to 100 liter per head per day may be considered adequate for domestic needs for urban communities apart from non-domestic needs as flushing requirements, which varies based on type of building occupancy. As a general rule of the following rate as per capita per day may be considered for domestic and non-domestic needs. For community with the population up to 20,000, water supplies through stand ports. For community with the population up to 20,000, 20,000 up to 20,000 means the small village and the small township, everything will be will included only. Maximum, if you are going to design the population up to 20,000 means you have to consider for the stand post. Street stand post means public tap. Public tap only, not private connection. For the up to 20,000, they will going to give you one stand post, not individual connection. For that one, we have to consider 40 liter per day. LPHD means liter per head per day. LPHD minimum. This is minimum. You have to consider 40 liter. You have to consider for total for each population. You have to consider 40. Suppose 19,000 population means you have to multiple 19,000 into 40. So you have to arrive the water demand for the particular population per day. And water supply through house service connection. If you are going to give service connection means 70 to 100 liter per head per day. 70 liter to 100 liter per head per day. So that village or township is connected by house connection means individual house connection, private connection means you have to connected you have to consider for each people 70 to 100 liter per head per day. For communities with population 20,000 to 1 lakh together with the full flushing system. So more than 20,000 up to 1 lakh people together with the full flushing system. Flushing system means domestic, and flushing means domestic means drinking water and drinking and other washing purpose, bathing purpose. We are using that domestic water. Flushing means only for toilet flushing, urinal flushing and toilet flushing. So for the flushing, so suppose some of the toilet flushing will not be there. So directly they will throw the water by using bucket or mug. So flushing means flush tank will be there. Flush tank and urine, for the urine also urinal flush tank will be there or flush hall will be there. That only they are mentioning, or full flushing system like that. So for the up to 20,000 people, they are not considered for the flushing system because the very poor people, they will not have the toilet also. They will go some open toilet also. Open toilet somewhere in the village, they will not use like that only. But toilet and all. So that's why they are considered 40 liter minimum. Now here for the 1 lakh people, 20,000 to 1 lakh people, they are considered with full flushing system. With the full flushing system, 100 to 130 liter per day, per head per day. So like that they are considered. So this only we are taking for the residential project. We are going to design the residential project means we going to take 100 to 130 liter because we are living in the city. So we will not have the open toilet and all. We have to have proper toilet with the flushing system. That's why we have to take 100 to 135 liter. So normally we will take maximum only for the water storage. We will take maximum. Maximum means 135 up to 135 we will go. Otherwise, sometimes client will tell you can also take 150 or 200 also you can take like that. Client will tell because they are going to invest money for storing the water and all. So that's a minimum requirement is 100 to 135. If it is client ready to invest for more water storage, you can also get input from the client. No problem. So minimum we have to give 100 to 135. So we will take 135 only for design normally. So for communities with the population above 1 lakh means together with the full plus system means you have to take 150 to 200 liter per head day. 150 liter to 200 liter per head per day with the full flushing system you have to take like that. This is for the luxury bungalow or everything we are taking to up to 200. Normal economic plot and all we will take 135 liter per head per day we will take. If you are going to design luxury building, luxury apartment, luxury bungalow, they have maybe bathtub and everything they will have. Swimming pool also they have. So that's the for the project we will take 200 liter per head per day like that we will take for the residential building. Out of the 100 to out of the 150 to 200 liter per head per day, 40 liter per day may be taken for flushing. This you have to note. 45 liter, or if you are going to design 135 liter or 150 to 200 liter per day, head per day, in that 150 to 200 liter, you have to take 40 liter per head per day for flushing system. Flushing requirement you have to take for your calculation. That I will explain in the tabulation. I will explain. For the 150 to 200, if you are considering your total requirement of water, in that water requirement, 40 liter you have to consider for flushing requirement. The remaining quantity for other domestic purpose only. So remaining quantity for other domestic purpose only. The minimum requirement for water supply for buildings other than residence shall be accordance with the table number 1. Other than table number 1, already we have seen this only this table only. So other than residence, you have to consider based on this one. And also the NBC also elaborately given for other than residence in table number 1. Water requirements for building other than residence, class 4.1.2. That one, factories including canteen where bathrooms are required to be provided. Bathrooms are required. Bathroom means bathing. You have to think bathroom means don't only not only toilet. Bathroom means with the including of shower. So that only bathroom. Here meaning is the bathroom means including of shower. Factories including canteen where no bathrooms are required to be provided. No bathrooms are required means there is no shower, only toilet. So like that you have to mean this word. So if you are going to provide in the factory with the bathroom or means shower. With the shower means for the domestic 30 liter per head or flushing 50 liter per head, you have to consider totally 40 liter per head in the factory building. If you are going to design the factory building, you have to consider 40 liter per head per day. If you are going to design the factory without bathing facility, so 30 liter you have to consider. Like that you have to mean. Hospital, for the hospital excluding laundry and kitchen. See note 2. Now for the laundry and kitchen they will take separate. So to say here the hospital excluding laundry and kitchen. Number of beds not exceeding 100. If you are going to design the hospital, that bed number of bed is not exceeding 100. Means you have to take totally 340 liter per head. In that 340 liter, 230 liter per head for domestic, for the flushing 110 liter per head. So like that you have to take. If you are going nurse home and hospital, hostels, office, if you see office including canteen, if you are office, if you are going to design the office, in that office canteen also is there means you have to consider 40 liter per head. 40 liter per head. In that 40 liter, 20 liter per head per day for domestic purpose and 20 liter per head per day for flushing purpose. You have to consider. Accordingly, you have to understand the things you can design. And clubhouse, you have to see clubhouse for every plot and residential building. You will give one clubhouse area. For that clubhouse area, you have to give 40 liter for the each occupancy. 40 liter per head per day you have to provide. In that 45 liter, 25 liter per head per day for domestic purpose and 20 liter per head per day for flushing purpose. You have to take this input from the LDC. Likewise, they are just every cinema theater, schools, education staff, visitor, everything they are given. If you are going to see the schools, without boarding facility means not hostel, only school. With boarding facility means with hostel, including hostel. Or without boarding facility means 40 liter per head for school students plus staff, everything you have to count. For each head you have to consider 40 liter per head. With boarding facility means you have to consider 130 liter. Shopping and retail mall, for the shopping mall you have to consider like the staff 40 liter, visitor 15 liter you have to consider. 5 liter for domestic per day, flushing 10 liter per head per day you have to consider for the visiting. Airport terminal, railway station, everything there, intermediate interstate bus terminal, metro station, everything they are given. Based on this only, you have to take the minimum water requirement you have to take. So how you are going to arrive? That I will explain here. I also arrived. Water demand calculation for the residential plot for the residential building. Typically, I have put here project name residential plot, ground plus basement 2 plus 24 floors plus clubhouse. G plus B2 plus 24 floors means G means ground floor plus B2 means two basements plus 24 floors. 24 floors are there. From the first floor to 24 floors are there. Plus addition to this clubhouse also is there. So this is the project description. For this project, we are going to design what for water demand or water balance it, whatever you can tell. Water balance it also same only. Water demand calculation also same. Both are same only. So here also I have provided A, B, C, D, E, F. For the each column I have put name for your understanding purpose only. You don't put while you are calculating, while you are working in your any organization, you don't put like that and all. For your understanding purpose, I have put it here. This yellow color highlighted things I only put for your understanding purpose. For explaining purpose, I have put. There also serial number 1, 2, 3, 4, 5. I have given. Area floor name I have identified. Area for ground floor, first floor to ninth floor, 10th floor to 16th floor, 17th floor to 22nd floor, 23rd to 24th floor. In addition to the clubhouse and the housekeeping, general worker, housekeeping worker. For if you are going to design residential building, for the residential building, housekeeping also is the housekeeping people will be there. Maid, housekeeping maid or people will be there. Visitor will be there. Visitors will be there. Visitors or guests. Everything you have to consider visitor only. Visitors are there. So like that, you got this is a typical tabulation for the residential building. You have to consider for all the every project you have to consider the visitors must. If you are going to design for the office building or a factory building, there also visitor will be there. The visitor also going to use our water and the toilet and also that's why you have to consider visitor and the housekeeping also you have to consider for the office building or factory or our residential building also. You have to consider. So based on that only clubhouse is not mandatory. Clubhouse is for not mandatory for all other project. You got to think, you got to check your project description clearly. Then only you can design. So ground floor. If you go going to ground floor how much is there? Only one floor. Number of floor will be only one. One floor only we are considered. Type of occupancy. What are the occupancy is there in the ground floor? Maintenance staff is there and security staff. Only in the ground floor there is a maintenance staff and security staff. No more any residential occupancy. Only what will be there in basement, ground floor, and everywhere car parking and security staff, maintenance room. Something only will be there in apartments. So that's a maintenance staff plus security staff. Two type of occupancy will be there in the ground floor. So for the occupancy, we have considered based on the client input, we get the 20 number of people's maintenance staff plus the security 20 number of staff will be there. Type of occupancy staff category only. For the staff category, you have to consider 40 liter per day as per the MPC table. Already I have shown the table. From the table, you have to consider 40 liter per day. In that 40 liter for drinking, how much I have considered? For drinking 30 liter I have considered. Remaining 15 liter I have considered. Remaining 15 liter I have considered for into Hachi. What is Hachi? Hachi is the for drinking. For drinking 30 liter. Here we are going to put domestic demand only. Domestic total demand for drinking only we are going to arrive. So that's why you have to multiple total number of occupancy and the total for the demand drinking water demand. You have to both if you are multiple means you have to get you can get the total demand for drinking per day. Total demand for drinking for the 20 people you can get a 600 liter. And if you go another column, K column, total demand for flushing. Flushing purpose, how much you will get? F into I. F means for total number of people. I means flushing per day. Flushing liter per day per head, 50 liter. So both you have to multiply 20 into 15. If you multiply means 300, you will get. So again, you have to both you have to or both you have to add, then you will get the total demand for drinking and flushing. Total demand for drinking and flushing 900 liter. L column equal to J plus K. What is J? J is the total demand for flushing for drinking. liter per day, and K is the total demand for flushing liter per day. Both you have to add 600 plus 300, 900 you have added. For the ground floor, you have to arrive 900 liter per day. For the ground floor, you have to arrive. So likewise, for the if you go next row, second row, first floor to ninth floor, first floor to ninth floor, how much floors are coming? 9 floors are first, second, third, fourth, fifth, sixth, seventh, eighth, ninth. So totally 9 floors are coming. So for the calculation purpose only, I have arrived here. So 9 floors are there. Type of occupancy, what type of occupancy I have put here? Here, single BH, 1 BH only, totally 1 BH only will be there. Number of floors, 9 floors are there. Each floor, 1 BH only will be there. 1 BH, how many 1 BH will be there? Number of units per floor. Each floor having 16 1 BHK plots will be there. Each floor, 1 BHK plot, 16 numbers will be there. 16 numbers. Total number of unit. How to arrive the total number of unit? D column equal to A into C. A is the number of floors. C is the number of unit per floor. Both if you are multiply means you will get the total number of unit. You will get total number of unit up to one floor to first floor to ninth floor. 144 unit you will get. 144 1 BHA unit you will get. So for the 1 BHA, how much the MBC told? For 1 BHA, you have to take four peoples per house. 4 peoples per house only minimum you have to take. So that only I have put here. So after that, total number of people you have to arrive. Total number of how you are F equal to D into E. D, what is the total number of unit? What is E? E is the as per NBC number, how much you are considered? 4. So 4 into 144, 576 you have to arrive here. So total number of people in the first floor to ninth floor, total number of people, 576 people are there. If you are considering 130 liter for each people, as per NBC liter per day per head. So 130 liter. In this 130 liter, you have to consider 90 liter per day for drinking purpose or other domestic purpose. 90 liter. For the flushing, 40 liter you have to consider. NBC also told for the flushing to 40 liter you have to take, like that they have told. So that's why we took 40 liter for domestic. Other things, other the remaining water, 90 liter of water we will take for the other domestic purpose we are drinking or some washing or some other purpose we are taking 90 liters. So likewise we got to split for the calculating purpose. Total demand for drinking per day. Total demand means how you will J equal to F into H. F, what is the F? Total number of people 576 into H. What is H? For the per day per person. If you are multiple both means you will get the total number of domestic water you will get for the 576 people you will get 51,840 liter you will get. Same thing, same wise you will get flushing also. For the flushing, what are the things you have to multiple total number of people for the individual demand 40 liter. 576 into 45. That only we have K equal to F into I. F into I equal to multiple. You will get 20,920 liter. You will get. If you are addition, both if you are addition means you will get 77,760 liter. You will get both. For the first floor to ninth floor, you will get 77,760 liter per day total demand.
Sir, 1 minute, sir. Sir, this drinking is there not drinking liters per day? This
Yes.
is from where we'll get from NBC or where?
So NBC told how much 130 liter per day you have to take for the occupancy. How much? 20.
Drinking water.
That only I am telling. If you see here what here they are told here for communities with population 22.
100.
1,000.
1
It's
lakh.
a 1 lakh. 1 lakh. How much you get? 100 to 135. This only, this
Hmm.
maximum only I took. 130 liter we took. Okay. In that one other 4.11 4.1.11 out of the 150 liter to 200 liter per day. 40 liter per day may be taken for the flushing requirement and the remaining quantity for the other domestic purpose. They are given one notes. 40 liter, if you are taking domestic, total domestic need 130 liter or 150 liter or 200 liter, if you are taking match, in that 150 or sorry, 150 or 135 or 200 liter, 40 liter you have to consider for flushing. So that only we took. Remaining things you will take for the other domestic purpose. Like that you have to. The minimum 40 liter you have to take for the flushing purpose. Flushing is the constant. Constantly you have to take 40 liter for the residential building. Other than residence, as per the table you have to take. So other than resident, they clearly they have mentioned. If you are taking the factory building, 30 liter per day for domestic purpose, flushing purpose 50 liter they have mentioned. Clearly they have mentioned. For the domestic purpose, they are given 40 liter for flushing. Remaining water you have to take for the other domestic purpose. Maybe for the house wise, each house not typical. No, for some of the house will take more cloth wash, more dishwash, everything. Some of the building family will not put more cloth washing and dishwashing and all. This will differ based on that requirement. So that's why 40 liter we will take the constant, remaining will put into flushing purpose, other domestic purpose. Likewise, I took here. If you take the 150 liter here, instead of 130 liter, if you take here 150 liter, here how much will come? 105 will come. If you subtract 40 liter from the 150, 105 will come. So 105 we will put here. Now I take 135 only. That's why minus 135 minus 40 liter, 90 liter only I put here. Okay. Are you understand now?
Okay, sir. Okay, thank you.
Likewise, I have calculated. If you go 10th to 16th floor, so 10 to 16 means 7 floors are there. So here in the 7th floor, for the 10th floor to 16th floor, 2 BHC only is there. 2 BHC, not single BHC, only 2 BHC buildings are there. So for that number of units per floor, 12 each floor 12 units are there. If you want to get the total number of units, you have to multiple with the 7 floors into each floor units. You will get to 84 units. Total number of units is 84 unit. From the 10th floor to 16th floor, you will get 84 unit. For the each unit, 2 BHC means you have to take 5 occupancy. 5 people going to stay in the 2 BHC building, 2 BHC house. So that's why you have to take 5 as per the NBC. 5 into 84, you will get the total number of people. 420 people will be there in the 10th floor to 16th floor. For each people, you have to consider same 135 only, 135 liter only, same thing only. So in that 130 only we are consider 40 liter for domestic flushing and 90 liter for domestic we are considered. So accordingly you have to design same thing only. Previously I told same thing only, same formula only you have to consider 56,700 liter only we will get. Because 17th floor to 22nd floor, 3 BHC will be there. How much floor? 17 floor to 22 floor, 6 floors are 17, 18, 19, 20, 21, 22 like that. 6 floors are there. In that 6th floor, each floor having 3 BHC only, not other BHCs. 3 BHC only having. So for the 3 BHC, how much is in each floor? 8 units are there. If you multiply in the 6 floors, 6 into 8, 48 units will come. For 48 unit, how much people going to occupy? 6 people in the each unit. So total people, if you want to get means, you have to multiply 6 into 48, 288 will come. So like that you have to calculate. For the peoples, you have to consider each people 130 liter per day. You have to consider same thing only 90 45 only, 90 for domestic, 45 for the flushing. So same way you have to calculate like this only. 23rd to 24th floor, two floors are coming. There, what are the type of occupancy is there? 4 BHK occupancy only is there. For the 4 BHK occupancy, how much is there? Six unit per floor is there. So two floors are there, 6 into 2, 12. So as per NBC, how much you have to consider for the each unit? 7 people you have to consider for the 4 BHK unit. 7 into 12, total number of unit into 7. You will get 84 people are, total people are going to occupy the two floors. So each people you have to consider 135 liter water demand, 90 liter per domestic and 40 liter per flushing only. So total you will get, total demand you will get 11,000 liter, 11,300 liter you will get. So other type of occupancy is there here. Other type, other than that, the residence, other clubhouse will be there. Maybe this is optional only. So lot of plot having clubhouse only nowadays. So you have to consider clubhouse. Sometime some other things will be there. That also you have to consider. Some of the residents maybe that the commercial things also will be there. If you go some other in Chennai also, residents will be there from the second floor or third floor. Other floor will be occupied for the commercial purpose. Commercial means some hotel will be there or mall, something will be mall something, some gymnasium, something will be there. So if you it is having means you have to consider that type of occupancy only. Here I have considered clubhouse. For the clubhouse, how to consider the population? Population for the clubhouse, you have to consider minimum 10% of the total population. 10% of the total population means you have to multiply these populations. Therefore, you have calculated 20, 576, 420, 288, 84. Totally, you have to count. Then from the count, total count, you have to get 10% for this clubhouse occupancy. 130 number. 130 people, 139 people going to occupy for the clubhouse. This is approximate estimation only. Maybe it will maybe vary. Maybe this down lesser or more. So for the calculation purpose, you have to take like that only. If the client is giving exact value, means you can take the client data only. If client is not telling any exact data, you have to consider like this one, like that data only. 10% of the total population in the residence. That the residence people only will go to the clubhouse for the gymnasium, for library, for other activities. They will go. So for the daily basis or weekly basis, they will go. They are only going to occupy. So that's why. As per the NBC, how much you have to take for clubhouse? 25 liter. Total 25 liter per person you have to take. In that 25 liter, 50 liter for drinking purpose. 50 liter for drinking person, and flushing, for the flushing 10 liter you have to take. So likewise you have to take for total demand. How you get total demand of drinking water, how to arrive from as per total number of people in multiple into uh, demand, drinking demand per day per person 50 liter. You multiple J equal to F into H. You multiple means you will get 2000 liter, 2085 liter you will get. For same thing for flushing also, 10 liter you are considering for each person. So 135, 139 person into 10 means 1390 liter you will get. If you add both in flushing, total flushing demand and domestic demand, you will get 3,474 liter you will get. Like that you will get. For the housekeeping, considering to 20% of the total population. Housekeeping means who are the people including here. Housekeeping means maid also is there, or the house worker. For the house worker also, each people will not be their house worker. Maybe the housewife will do the all the works. Some of the house only will have the house workers or maid, housemaid, everything will be there. So that people only housekeeping people we have considered. So for that consideration, you going to take total population. Total population, in that total population, you will take 20% of the total population. Considering 20% of the total population, you will get 278 people. You will get. For that, each people you have to give 40 liter. As per the NBC, you have to give 40 liter per day. You have to give. Then 40 liter breakup will be 30 liter per day domestic purpose, 50 liter per day for flushing purpose you have to give. So accordingly you can calculate. So you will get 12,510 liter you will get per day. For the visitor, how to arrive for the visitors? For the visitor, you get to arrive 5 to 7% you can get. Minimum 5 or maximum 7% you can get. Minimum only I took. Some of the area you will get more visitors, more than 7 people, 7% people. So that time you will get input from the client only. So here your standard calculation only, I took 5% of the total population. If you count the total population, from the total population, you will take 5% of it, 70 people will be there. 70 for the visitors, you will take 25 liter per day per head you will take. In the 25 liter, 50 liter for flushing and 10 liter for flushing I took here. If you multiple here, 1050 liter will you will get for domestic purpose, 700 liter for flushing purpose you will get. Both if you are adding means 1750 liter will come. So total demand for drinking is 1,35,195 liter you have to give for drinking other domestic purpose. For this project you have to give 1,35 liter, 1,35,195 liter you have to give, approximately 1,30 liter. Otherwise 135 cubic cubic meter of water or metric ton of water. So like that you can also call 135 cubic meter of water or 135 kiloliter or 135 metric ton of water. Everything you can also call. No problem. 135 kiloliter is the easy way to call. So 135 kiloliter, approximately 135 kiloliter you have to give for the domestic drinking purpose. 68 here if you go the flushing demand 68 kiloliter or 68,000 liter you have to give. If you adding both, total demand is 2 lakh liter, 2 lakh 3,000, 2 lakh 3,350 liter is coming. Approximately you can call 200 kiloliter you have to give, 200 kiloliter you have to give for this project. So 200 kiloliter means 2 lakh liter you have to give, approximately 2 lakh liter you have to give for the this project, total project. So from this water demand, how you arrive the STP capacity and other things, how you going to arrive the STP capacity? From this total demand, you have to get 90% of the STP for the STP capacity, considering diversity factor 90% in the total water demand. From the total water demand, you have to put 90%. 90% of total demand only.
Sir, hello,
Tell
hello,
me.
hello. Sir, on doubt is sir, what is mean by STP actually? Sewage treatment plant like that or?
Sewage treatment plant only.
Oh, oh,
Okay. If you want to ask any doubt, you can separate time is there. You can ask in between. You can ask. You don't ask. You disturb only for other people also. So after end of the session, you will ask any doubt. No problem. STP means sewage treatment plant only. Considering diversity factor for 90% in the total water demand. This is the total water demand. 2 lakh liter only. 2 lakh or 2,200 kiloliter. If you put 90%, you will get 182 kiloliter. 182 kiloliter or 182,984 liter of capacity. So normally we will get how we give the capacity. We will give the capacity kiloliter only. So you will tell 180 round of 180 kiloliter of your capacity will be STP capacity will be 180 kiloliter or 180 cubic meter per day. You have to provide for this project. Available treated water from the STP. Available treated water after the giving the input to the STP. What will happen? It will treat the water. It will treat the sewage water. 1 minute. After treating the STP, if you are giving input 100 liter means how much water you will get. If you are giving input means input of 100 liter of water means you will get 80 liter of water only. Other things will go for the waste and other sludge. You have to remove the sludge and everything, other waste and all, for the 20 liter will go for the sludge. So that's why we will get treated water from the STP, 80% only we will get from the input. So input you are giving 182,000, you are giving 180,000 liter, you are giving input, you will get 146,000 liter, you will get treated water. What you are going to use the treated water? For this treated water only, you have to use for the flushing. Total demand for flushing is there now. First, you will refill the water for 2 lakh liter. You are going to refill the water 2 lakh liter only. First, you are going to refill. Then next day, you will get to 146,000 liter. Where you will get 146,000 liter. Where you will get from the STP only. You will get this STP treated water only. You can use for the flushing. From the next day onwards, you will get. You can use this STP treated water for the flushing. STP treated water, how much you will get? 146,000 you will get. Our demand is how much? Our demand for the flushing per day 68,000 only we will our demand. Remaining how much is the excess treated water? How much is the treated water from the STP minus total flushing water of demand? So STP treated water from the STP is 146,000. Our demand is 68,000. After putting subtraction, your excess water will be 78,000. You will get. What you are going to do the excess water? You can't do anything. You have to throw out only. Excess water will be go into the external source only. You throw into external source or external public sewer, or you put into the tanker. You throw into the public sewer or any river or something. After treating this one, you have to dispose. That's all. You can't store. For the storing and all, you can't provide any storage space and all. So you have to throw to the external source only. In this table, we are not considering fire water storage and all. In this table, only for domestic and flushing only. If you are going to design the fire also for this project, you have to consider the fire water demand separately. Whatever it is, as per the code, whatever you have to store, you have to consider separately. 200 cubic or 400 cubic meter also you can consider accordingly for your as per your code, fire code you have to consider. Okay, in this project we are consider 400 cubic meter we have considered for this project, but here I have not shown here. If you are going to design fire water, as per the code, we have to show here for the one. We have to put one row for the domestic fire water. For the fire water, 2 compartment. Each compartment having 200 cubic meter liter. 200 into 2, 400 cubic meter of water we have to store for the fire water purpose. So like that we have to put here. This is the water balance sheet or water demand calculation. Okay. Accordingly, you have to arrive the water storage requirement, water underground storage, above ground storage. Yesterday, last class, I can teach it now. So accordingly, what type of storage you are going to design, underground or above ground or overhead tank, like that you have to design. So last class you took this and all, no? So accordingly you have to take the over fire water demand underground if it is underground or if it is above ground or if it is overhead. Fire water as per your requirement only. Normally we will go if it is in our domestic purpose. Normally we will go or if it is in water tank we will go for this syntax tank only. If you in your project having fire water storage also in terrace means we will go RCC tank only because in the fire water maybe we have to put 50 liter or 20 liter 20 cubic liter we have to put. So for the large storage you have to go for RCC tank only. If you don't have any fire requirement in your project you have to go small tank only for half day storage you have to store there roof. Your roof you have to store half day requirement only. Other the 1.5 other the actually normally as per the NBC we will store the water how much we will store 2 days requirement we will store. So here I have arrived total requirement is how much here we have arrived total requirement 135 plus 68 we have arrived 68,000 liter we will get it from the STP only. So for the domestic purpose 135 cubic meter liter per day we have to store per day 135 liter means normally we for the safer purpose safety purpose we will provide 2 day storage only for the project. 2 day storage means how much will come 200 270 cubic 270 cubic liter 135 into 2 270 cubic liter cubic meter of liter you have to store for this project minimum requirement in the 270 liter of water half day requirement you have to store in the roof. Other things you have to store in the underground or above ground in the ground floor itself. That roof is not mandatory, actually roof is not mandatory. For the concept I am telling minimum half day only we will give in the roof. Otherwise if the client is not ready to store in a roof the water means you have to give all the 2 day storage in the normal underground or above ground only below floor only you have to give. So minimum 2 day we will give for the safety purpose. Suppose they don't have water from our national source or lorry strike or any other day means one more day you can use the storage water. So if suppose client want to invest more money for storing the water means you can store up to 5 day or 1 week also no problem. You got to think the storage space also store water how much storage space is sir that also you got to think. So that's why all clients are going to store 2 day requirement only. The clients are not ready to invest most of the clients are not ready to invest more money for this residential project and also. If you want to if you are going individual owner single bungalow means they are ready to store 10 days water also. Small bungalow means if you think about our house, you don't have any borewell, you are going to get water from the external source, lorry water means how much you are going to store. Daily you will not get water connection, water lorry no. So you have to store at least 15 days, 10 days minimum. That only you will, water problem will solve. Otherwise, daily basis storing is you will get more problems. So that's why individual owner means you will store for a minimum 10 days and 15 days and all. So like that you have to think and give the project requirement. This is the water storage and the water demand calculation. They will call as water balance sheet also. This only schematically they will put the water balance chart. This value only they will put schematically. How much water is coming here, how much water is going there, how much we are getting from the STP, how much we are going to give for the STP, like that and all. They will put one schematic diagram. So that only water balance chart. This is water demand calculation. From this data, from this tabulation data, you will arrive a small small chart that is called water balance chart. So both are representing the same value only. Okay, this is enough for the to design the water demand calculation for this project. For the better understanding purpose, for the client better understanding purpose or representing purpose, you can use the chart based balance sheet, chart based balance sheet, whatever it is, you can back that and all. Here I can't, here I not showing the water balance chart and all. You can also show, no problem. You can also put how much people are going to one rectangle, how much people is going to occupy the one rectangle. For the people, how much domestic water, total domestic water needed, 130 kiloliter. And for the flushing, 68 kiloliter. Both how much is the 2 lakh kiloliter. 2 lakh kiloliter, how much you are putting into the STP? 182 kiloliter feeding into the STP. How much you are getting from the STP? 146 you are getting the STP. Remaining this 146 you will use 600 kiloliter going to use for the flushing purpose. Remaining of 78 kiloliter you are going to throw into actional. This is the chart. Summary of the water demand. That's all. Like that, you have to show. Do you have any doubt in this? Are you hearing my voice?
Yes, sir. Yes, sir.
Do you have any? Okay. After taking 10 minutes break, we will go for another chapter.
Sir, this water demand, based on water demand only pump capacity will get a.
Pump capacity you will not put for the water demand and all. Pump
Okay,
capacity
okay,
is separate. So
okay.
mm, if you are going to design a booster pump or transfer pump means how much? Suppose you are putting underground water.
Okay.
And for example, like you want to transfer 10
Okay, sir.
cubic
Okay,
meter
sir.
of water, 10 cubic meter. So, how much time it takes? 4 hours or 8 hours it will take. Based on the 8 hours, how much liter per second you will put? 10 liter of water means cubic liter of water underground you will put.
Sir, Ravi Kumar sir, your
What
voice
is
is
think
breaking,
one?
sir.
How it is okay?
Yeah, okay, sir, but we didn't hear anything you said before. It was breaking.
Okay. Actually, for the capacity of pump and we will take some separate class is there. So, based on this water demand and all, we will not put any pump. First, you have to keep water demand is separate, pump capacity is separate. The pump capacity and all based on our flow requirement and lifting capacity. How much flow rate is there? That and all you have to consider for the pump head. The flow requirement, how much flow you have to transfer the per minute or per second per hour. So if you are taking for the rough calculation for the 10,000 liter, if you are transferring 8 hours means per minute 20 liter you have to transfer for 20 liter of water per minute you have to transfer like that. If you are getting the head means you total building height and pressure loss everything you have to tell. That and all different concept. This is different concept. Water demand is only for the water storage purpose only. For the project, how much water you have to store. That is one base we use this there. For the NBC base we have to calculate. Simply you can't put some 10,000 liter, 1 lakh liter like that. You don't put it simply. Based on the NBC reference, you have to calculate. If they are not ready to go for NBC, they need more water. The client is required more water. Then the NBC requirement is ready to put. They are have more money, means they can ready to put, no problem. We can design, but for the designing we required some base data. No, for the purpose only we are referring the NBC calculation. This is very simple calculation, but you got to consider the concept of calculation and everything. You got to consider that only you have to keep in mind. Okay, pump calculation and all I will take separate class is there, separate chapter is there. There I will explain everything. Okay, we will take 10 minutes break. After that we will check another chapter.
Okay, sir.
Yes, sir, assembly.
Okay. Last class we have seen water storage, underground water storage, above ground water storage, overhead water storage and all. Now we are going to see drainage disposal. After that, pump head calculation. So now we will see drainage disposal. What are the method we are going to dispose the drainage? First is septic tank. Another one is underground sump with lifting pumps, sewage treatment plant, effluent treatment plant. So septic tank. These are we are going to use in small kind of projects, small buildings, individual buildings, not apartment and all. Only individual building only. We are using septic tank and all. So actually, these are the civil part of calculation. Everything the civil part of calculation. We don't want to put any calculation for the septic tank and all. This is a civil work. Learn for civil work only. So you have to know the concept of a septic tank and all. Inlet water, our inlet drain water will put into one chamber. So here one in this chamber separate one scum layer and a sludge layer separately will come. Scum layer means floating material, and sludge layer is little bit dense, more dense than water. So that's why it will go under the water only. So after the water, clear water will go into the another chamber. Again, some little escaping scum will again will float, again will float. Or scum always will create in the sewage. Scum means what? That bubbles only, bubbles. You can also see in seashore. See, if you go in the seashore, lot of bubbles will come. That is called scum. So that scum will automatically will develop in the sewage. So scum always will float in the water only. Now it will always it will this density will lesser than in water. So that's why it will float. So clear water will go into outlet pipe. This outlet pipe will connecting into one soak pit. This is the clear water. This water will entering into the soak pit. In this soak pit, water will soak here. It will pass into the earth, natural earth. The system will be there. For the cleaning purpose, access hole we have to provide access holes, everything. For the cleaning purpose, for removing the water and all, access hole, access manhole will be there. For the vent hole also we have to provide. So in the soak pit also, these are the materials will be there. So the connecting inlet pipe will be connecting into the center of the chamber, breath chamber. Outside the chamber, the stones, they will arrange the stone and all. Stone masonry, again stone masonry wall will be there. And after that, outer casing wall also will be there. 300 mm outer casing wall will be there. So here also one manhole will be there and vent pipe will be there. This is the typical arrangement. These are design will be this design will be done by civil department only, not by you, not this scope is only for civil only. But you have to know the concept of septic tank and all. That's why I am showing here. Septic tank having chamber, two chamber or three chamber, four chamber, multiple chamber will be there based on the capacity. After that, this outlet pipe will be connected into the soak pit. This soak pit may be 1 number or 2 number, 3 number based on the capacity. 2 or 3 numbers will be there. This is the typical arrangement of septic tank and a soak pit. For soak pit is only for soaking the purpose. After entering to this sewage into the septic tank, the sewage will be digested. After digesting, this sludge layer will go into down. The scum layer will go into up. This is the concept of septic tank. The clear water will go into the soak pit. The soak pit will soak the water into earth, natural earth. This is the concept. That's all. This is called septic tank and soak pit. So another one method, what if you don't have septic tank or any other drainage arrangement in your building or near to your building, how you going to dispose the water, drainage water? By pumping only. You can't you can't take the water by bucket or anything. You have to put one underground pit, drain pit, underground drain pit and a submersible pump. You have to put a submersible. Why submersible pump? If you put above ground pipe, the priming also needed. Priming also needed for the this contaminated water. So that's why always in this football will not work. Always football will not work because of contamination. So we have to use, if you put a above ground pipe, above ground pump, you have to provide some priming arrangement for the pump. So that's here we are putting underground pump, that is called a submersible pump, for to avoiding the priming and everything. So better to maintenance also. So that's why we are using the submersible pump for the underground drainage disposal. The like this situation, the inlet water will be connected into the sump. The sump. After reaching certain level, the pump will launch automatically. The water will be connected into the external drain. Somewhere will be there. Some 50 meter, 100 meter distance will be there. For that situation, we will use. Suppose our site will be lower than the our site will be lower than the external source. External drain source means you have to use the underground pit only. Underground pit with submersible pump. So like that you have to put. This is the typical arrangement. In this pit we have provided one vent pipe also. For all the drainage pit will have vent pipe arrangement also. So then only our pump will work without air locking. Otherwise, if you not providing any venting arrangement, our pump will get airlock, so our discharge will not come. The pump also will collapse. Pumping system also will collapse. That's why you have to provide a venting arrangement. For the purpose, we have put one venting arrangement. The outlet pipe is connected into main waste line. Somewhere for this main waste line is there. We are connecting there with using check valve and gate valve. Everything is there. First, we have okay now. Hello? Hello?
Yes, sir. You can start. We will see.
Okay.
Still, your voice is breaking, sir.
Submersible pump outlet. The outlet will be network problem is there. They are not power actually. Now it is okay. Hello. Now it is okay. Now voice is okay.
Okay, sir. This one
Okay,
okay.
sir. Okay.
Okay.
Okay. This is the typical arrangement of submersible pump. This submersible having bottom suction. The outlet will be in side of the pump only. This outlet will be connected into upwards direction. This water will be discharged into external. So like that will be there. This pump will be always submerged in the water only. So that's why for this pump the priming is not required. The self-priming pump. This will be self-priming pump. That's why we are using. So if we are putting above ground pump, we got to put priming arrangement and all. So that's why we are preparing for the submersible for the drainage, all the drainage. So this is the pit option, actually drain pit option. Previously we have seen the septic tank and another one is drainage chamber or pit with pumping arrangement. Another one method is that if you have any public drain, we can also directly connect. That is one option is there. From your building, you can directly connect it into the public manhole. That is one option is that is one disposable option. Another option, if you don't have anything, these are the if you don't have septic tank and the public connection and the drainage this kind of drainage dispose, we have to go for the STP, sewage treatment plant. Sewage treatment typically this is the sewage treatment plant typical arrangement. Actually, this is the image. It's a large type of sewage arrangement. This is using for the township, big township or the big township. Some 100 million liter, 200 million liter like that only they have arranged like this. This in right side. This is the small arrangement of sewage treatment tank. This is a above ground tank also, along the above ground tank. The left side is the large arrangement underground tank. These are the underground tank arrangement. See, if you are putting into water in the sewage treatment, this water will be treated and filtered into sludge separate. This will separate the sludge and the water will be separate. After treating the water, we can use for the flushing purpose and or irrigation or other using purpose. You can also use for the chiller cooling tower water, cooling tower water also for the this flushing water can be used for the cooling tower also. Water also. So this is a schematic of the flow diagram of the sewage treatment plant, typical sewage treatment plant. The inlet sewage from inlet sewage is going into bar screen chamber. First of all, this is the first chamber. We got to connect the sewage pipeline to the bar screen chamber. This is the entry of the STP. This is the entry of the STP. Sometimes, if you have any hotel project or a very large project, you have to connect it to the oil and grease trap. Normally, the bar screen itself having inbuilt grease trap on the bottom top. Inbuilt grease trap on the not bottom trap, grease trap only. Grease trap or oil trap will be there. Inbuilt. In this schematic, they are shown separately. Canteen drain, oils, grease, grill trap like that they are separated. But nowadays they have inbuilt oil in the grease trap with the bar screen chamber. Everything is there. You have to connect it here only first. After the bar screen chamber, what it is happened? In this bar screen chamber and the grease trap, the unwanted in the grease trap, unwanted oil and everything you have to remove. You will remove the unwanted oil and grease. You will remove. In this bar screen chamber, you will remove the solid particles, foreign particles, some plastic material, polythene cover, paper, and the other particles. Everything you have to remove. If you see in the sewage, everything will go. The sewage is empty, everything will go. Public drainage, everything will go. Instead of sewage, this polythene cover and water bottle only, water bottle, soda bottle, beer bottle, everything will be there in the sewage. That things they have to remove first. So for the purpose, they will use bar screen chamber. In this chamber only they will remove all the solid particles. After the removing oil and grease and the solid particle, This water will go into the depressurization tank. This is the second chamber. In this depressurization chamber only, we will put some chemicals. We will put some chemicals. So after the chemicals, this will go into aeration tank. In the aeration tank, what it will happen? In the aeration tank, the blower will be there. From the blower, air blower, from the air blower, we will put the air into the aeration tank. Bottom of the aeration tank, we will put aeration bubbles by pipeline. Lot of air bubbles will go into the aeration tank for growing the bacteria. For growing the bacteria only, we are putting the oxygen. Oxygen only we are putting here. What is the temperature? This is maintaining the temperature of average temperature of 30 degree. 30 degree we will maintain here. After putting the aeration, what it will happen? This sludge will digest. We are putting this air into up to 4 hours. This sludge will digest by natural bacteria. After digestion, this sludge will go downwards because this sludge will density will more into comparatively to the water, so it will go into down. The scum will go into up. Same as the secretarial concept only. This clear water from the aeration tank, the sludge water, clear water will go into the settling tank or clarifier tank. This clarifier tank, after going to the clarifier tank, here clarifier mechanism will be there. In this clarifier mechanism, there is no bacteria mechanism. This is mechanical type filter actually. Here some plate, filter plate will be there. In this filter plate, the water will get filtered. After this filter, this water will go into the clear water sump. The rejected water in the clarifier, in the clarifier will go into the return sludge into the aeration tank only. It will not go along into the forward. It will go return to the aeration tank. Here again the same process will happen. So like that only. This filter water from the clarified tank, settling clarified tank, will go into the clarified clear water sump. Clarified water sump. It will go into the clarified water sump. In this sludge, from the settling in the bottom, that the sludge will settling now. That the sludge will remove by the pump. By gravity force, it will remove. The sludge will go. The excess sludge will go into the conditioning process. For the conditioning process, after the conditioning process, it will go into the dewatering system. Dewatering means it will get squeezed. The sludge will get squeezed. After the squeeze, water will get separate and solid will get separate. So like that only. So from here dewatering, the the extracted water will go into again utilization tank. Squeezed water means juice. Like that juice only. Juice we are extracting. This juice will go into utilization tank. After the sludge will go into the dewatered sludge by gap. Dewatered sludge, gap type sludge will go for the disposal. They will dispose by into lorry. So like that it will be there. So after going to the settling water into the clarified water sump, after the clarified water sump, we will supply into the sand filter by using the pump. Before the clarified water and in between the clarified water and the sand filter, we use the pump for feeding the water into the sand filter. What purpose we are using the sand filter? This is the pre-filtration. For the pre-filtration, if you have any further solid material in the water, it will filter. Solid filter. Some of the modified multimedia filter also is there. Media filter also is there. But also they will use. This is the typical arrangement. So this is the traditional method of STP. So that's why here they put sand filter. After the sand filter, the filter water will go into the activated carbon filter. In this activated carbon filter only, you will filter the bacteria and virus and all. And some other germs. You will kill the germs here. So you put the activated carbon filter for clean the bacteria and the germs. After you get filter from the activated carbon filter, you will pump it into the treated water tank. Like, from the clear water, from the activated carbon filter, you will put into the treated water tank. After the treated water tank, where you got the water softener. You take the water from the treated water tank by using the pump. You put into the water softener tank. Water softener tank. Here, what it is happening? Some softening process is happening by using the chemical. They add some chemical for softening the water. So softening the water, they use chemicals based on the water test. After that, they will put chlorination. Chlorination means chlorine. They will add the chlorine by liquid chlorine or gas chlorine. They will add for maintaining the fresh water to eliminate the bacteria growth, bacteria virus growth. They will add the chlorine into the water. That is called chlorination. Then they will supply into the network for the toilet, gardening, etc. For irrigation, they will supply into the network. This is one method, and another one method is that treated water from the treated water tank. We will put into the water into micron filter. This is advanced filtering method, micron filter. This water will go into the micron filter. After that, after that micron water filter, this will go into the ultra filter. Micron filter. This is another more advanced method is ultra filter. Again, from the ultra filter, you will get fine filtered water. After that, you put a reverse osmosis RO filter, reverse osmosis filter. So after the RO filter only, you will get the taste of the water, like as cane water. Taste of the water. You can also supply for the potable distribution, potable water supply. So potable means drinkable water. Like that is that. Normally in our India, in STP water, we are not using for the potable purpose. We are using first option only. We are putting into the toilet and the gardening purpose only. In Singapore only, in Singapore and Gulf country only, we are using micron filter, ultra filter, RO filter for treating the STP treated water for drinking purpose. And also another one filter is there, ultrasonic filter, ultrasonic waves. They will put ultrasonic waves into the water for this killing the bacteria and the virus and other germs. Ultrasonic waves, that type of filter also is there nowadays. So this is the typical process flow diagram of the STP. So you have to know the process. You don't want to design the STP. STP is a separate chapter actually. The plumbing engineer will not design the process of the STP, but we have to know fundamental process of the STP. So then only you can understand how what are the things happening and all. So that's why you have to understand the process of STP. After this treating only, we are using the water for toilet flushing, gardening, etc. So another one thing, so this is domestic waste. These are the domestic waste is domestic and our human waste is treated by STP sewage treatment plant. If you are using uh, if you are using the industrial type of project and commercial project, like that means we got to go for effluent treatment plant only. That process is a little more complicated than the STP. Based on the what are the contamination is there in the drain. Based on that only, they will decide the process of effluent treatment plant. This will not be well. This may be varying for the project requirement. Which project requirement? If you go the pharmacy project, and it is different method will be varying. If you go the oil and gas refinery project, that ETP will be varied from the pharma project. If you go some other hotel project, that will, from the hotel you will get oil and some other chemical only. So this separate process will be there. So based on the contamination of the drain. So the ETP is not like STP. It is a complicated structure actually. So this also you have to know the fundamental process of the ETP. So here I am showing the ETP flow chart. In this ETP, raw effluent in first same as STP only. Raw effluent. This is the drain. Raw effluent you are connecting into the after oil with restart only. After the oil with restart, you are connecting into the utilization plan. So in the utilization, lime dosing also happening. Lime dosing. They have put this lime.
Sir, screen is not shared, sir.
Still you are not.
Oh, screen is not visible, sir. Only blank space.
How it is visible?
No, sir. Only blank is.
It's visible.
Okay, na?
Screen is visible. Yes, sir. Visible.
Okay.
It's ETP process, no?
Yes.
Now it's done.
It
Now
is
it's done.
visible now. It is visible for all people now. Okay.
Yes, sir. Yes, sir. Visible, yes, sir.
So this raw effluent
Yes.
is going into the oil and grease shop. After the eliminating the oil and grease, this raw water will go into the dry water will go into the equalization tank. In this equalization tank, they will add some chemicals like lime dosing and some other chemicals they will add. After this adding this, they will put the pump. They will pumping into flocculation tank. This will go into the flocculation tank. After the flocculation tank, it will go into the primary clarifier. From the primary clarifier, same as that STP only, the clarifier, some sludge will remove, the clear water will go into our next stage. From the primary clarifier, they will put some pump for removing the sludge. This sludge will go into again the utilization tank only, like that only. From the primary clarifier, the this clear water will go into the aeration tank. In this aeration tank, already I told you aeration pump, air blower will be there. From the air blower, the air pipe will be supplied into the aeration tank, bottom of the aeration tank. Here bubbles will come, lot of bubbles will come to grow the bacteria with the temperature of average temperature of 30 degrees Celsius. Again, after this aeration, that sludge will get to digest. After the digestion of sludge, the clear water will get upwards, sludge will go down. In this variation also, they will put this pipeline with the diffuser. Diffuser means supply the air. If you go in HVAC system, the supply air that will go connected into the diffuser. So the same way, here also they will use some diffuser in the aeration tank bottom for supplying the air. So after getting the clear water from the aeration tank, the water will go into the secondary clarifier. The same process will happen. What the primary clarifier is doing the process, same process only will do the secondary process clarifier also to remove the fine sludge. That fine sludge will go into the sludgy pump, and from the sludge pump, the sludge will go into the sludge drying bed for secondary sludge. Previously previously we have provided in front of primary clarifier, one sludge bed also we have provided. After that, aeration tank, we are providing secondary clarifier. For the secondary clarifier also, we have provided one slightly drying bed or drying the slides. After the drying the slides, it will go into disposal with lorry. From the secondary clarifier, the clear water will go into the oxidation tank. Oxidation tank. In the oxidation tank, we will provide hypodosing, some chemical. They will put a chemical that is called hypodosing. This oxidation in this tank, oxidation will happen. After the oxidation, the water will get further filtered. Again, the filtered water will go to V-notch chamber. After the V-notch chamber, the treated effluent for the disposal. This from the V-notch chamber will go to the water for the storage purpose or treated effluent for the disposal purpose. This water will dispose into public drain or some other using purpose. This water we will not drink it. This water we will not use for furthermore also. Only we are disposing the water to the atmosphere person. For the cleaning our safe atmosphere purpose, we are treating and disposing. If you are not treating this water, our atmosphere will get polluted. That's why we are treating and disposing this water. This is the typical flow diagram of the effluent treatment plant (VTP). This is the typical. Lot of process. If you go to some other oil and gas project or pharma project, lot of process will be there. You will not understand also that much process will be there. But this is a typical arrangement. This is the fundamental arrangement. In this fundamental arrangement, they will add some other material, other chemical, other tank, everything they will add. Lot of things based on the requirement. They will add extra more chemicals, chemical tank process, and all everything they will do. So like that will be there. This you have to keep in mind. So do you have any doubt in the STP, ETP or drainage disposal system?
Sir, based on our delivery of means water amount, the plant size will be bigger or smaller.
Yes, actually previously we have put in for the domestic purpose, we are using the STP. For the STP capacity, we have to take the day basis, 1 day store water demand, 1 day the water demand only. We have to take. Actually, if you are your water demand is 100 KLD, your water demand is 100 KLD, but you are not going to provide 100 KLD capacity of STP because some water evaporation also is there. Water evaporation is there. Water loss also is there. Sometimes you are going to wash the car also. Sometimes you are that water will spill into some other area. So that's why we have to provide 80% of the 80% or 90% of the diversity factor we will take for the STP capacity. So 100 KLD means we have to provide 90 KLD only for the STP capacity. So that only I also told in previous water demand calculation.
Yeah, okay.
Diversity factor that I have told. After that, treating the STP, if you are feeding 100 KLD into the STP, there are some lot of losses happening due to the process. If you are going to remove the sludge and you are adding the water, chemicals and everything is there. Lot of evaporation also is there. After the losses, you will get furthermore down only again 80% only from the input water. So that's why loss is there for every time. So first you have to arrive the total demand water demand 1 day water demand. From the 1 day water demand, you have to give the 90% of the electricity factor for the STP. After that, output water, you have to take the 80% of the input water.
Okay, okay, sir.
That is the concept. This may be vary based on the practical condition. This may be vary as per the so some of the inefficient STP process also is there. If you go inefficient STP process, lot of water will waste. The water will go into the waste itself. Lot of waste will happen. If you see in our house also, if you put the RO system, lot of outlet drain water will go always. Some of the costlier, if you put in some of the costlier lesser water will go for the drain. You will get filter water more, but the drain water will go into less. If you are purchasing very bad quality or local material, a lot of drain will go, but you will get a little filter water only. That's in the same plant the same process also. Suppose you are purchasing inefficient STP, your outlet will be very less. Input 100 liter, if you put 100 liters, yes, your outlet is some 60 liter only will come. So you are going to waste the water in the drain itself. So like that is done. So you have to see the practical condition and all. This is the fundamental typical calculation only. If you go into the project, you have to ask the vendor what are the efficiency of your STP, how much water will give the after treating the water, everything you have to ask.
Okay.
Then only you will get the exact efficiency of the STP. Then only you can also assume the outlet walls, water and everything. Like that is.
Okay. Thank you.
Okay. Now 2 o'clock is over. Now here a lot of network problem and everything is there. We will take next class computer calculation and all. Freshly we will start. If I am starting this one also, I can't complete this one. This calculation and all is there. Okay, next week class we will see the complicated calculation. Then further more chapter. Okay, we will complete the class now. Thank you.
Sir,
Tell me.
sir, in last class now there is one doubt, sir. Actually, the slope calculation for piping, drainage piping. That 1:75 and 1:100 we are putting, sir. That is from NBC or we are directly putting that 1:100.
Actually, for the calculation purpose only, I only put to that one. So you have to calculate that practicing purpose only. I only given.
No, sir. Yeah.
But for the slope, you have to take from the NBC only. So in that NBC for sewage pipe, they also provided for the 100 MB, 100 mm dia, so only 70 only they are given. For the flow rate of 0.75 velocity, 0.75 meter per second velocity. If you go more size, more pipe size, that also they are given minimum slope they are given. Otherwise, if you go 600 mm pipe size of 500 mm pipe dia, based on the formula only you have to go. So
yes, sir,
NBC tabulation is for the small pipe only, standard pipe only. So another one method is there. Based on the formula only we have to go. That chapter next we will take. So one by one I am going. So everything I will not confuse everything, but one step by step I will go. Then only you will get understanding.
Okay.
With the formula means you can also change the slope based on the velocity. If you change the slope, the velocity will increase or decrease. So based on the site condition also, we can provide the slope or based on the level also we can change the velocity and all. That is there. We take in future class.
Okay.
Okay. Thank you.